So in this chapter, I want to talk about activation function. And therefore, let's go back to our neuron or to our concept of a neuron, where we have different inputs, then the corresponding weights W, and also the bias, and it generates an output. What is done next then is that we pass this output onto a so-called activation function. Because what a neuron actually does internally, and also what the biological neuron does, is that at a certain level of stimulus, it decides whether it just fires, it generates an output, and pass it on to the next neuron. So when it, so to say, is active and passes on the information. So therefore, we need to introduce something like an activation function, and that generates the actual output. So we just put something in between, and typical activations functions are, for example, the sigmoid or arcus tangents, or the ReLU, which is just a linear unit, so to say, and passes on only those values which are created in zero. And there are many other activations functions which are more or less similar. If you look at the arcus tangents and also at the sigmoid activation function, you might notice that for large numbers, the derivative, so the slope, is almost zero, and it also will play a role at other networks, and in particular when we have very deep networks or when we have recurrent neural networks, that's more beneficial to have activation functions where the slope is relatively flat for large numbers. And so what it does in principle, it kind of maps the input, which goes from minus to plus infinity to a certain interval. So it really depends on the activation function. And in our case, we want to use the ReLU function, and we also want to set up a class for that as before. So the same idea as before, we want to set up a class in our module, and we will also create a forward method, and then also later we will want to create a so-called backward method for the backpropagation. And this class is rather simple. So we just have to take the maximum in the input between 0 and the actual input value, and then just pass it on. So that means everything that is below 0 will be ignored and set to 0, and then we just realize or just perform the calculation of the so-called ReLU activation function. So therefore, we can, in principle, just already go back to our user interface. And also want to add a new chapter again. So let's just go back to our work folder, create a new folder, and we just call it 3 and an activation function. And let's also navigate to that. And then we just go to our module, and then we just add this particular class of the activation function. So we just, what I also do usually is then, because we will add a few more classes, I just always add a line of those hashes so that I really see then, okay, if I just scroll through my code, there's been another class, because we will add a few more, and that's why I'm doing that here. So we just add a new class. And we call it activation ReLU. We don't need an init, because we can just pass it on, so to say. We don't need to initialize anything. And we just create a forward method again. And we feed in the inputs. And it just generates an output. And also, of course, you want to check whether this function really works and whether it really makes sense. But that's pretty much it for now. And let's also save now our function, and also just make sure that we save it in the right folder. So we just go to this here, that we just save it in the right folder. Okay, so also the test routine, we should save in the right folder. So that we have everything in the correct folder. All right, so then we just import our network again. And of course we have to compile first, sorry for that. And then we import it. All right. So then there should be our activation function. So we see it already here in the tree, and it also has a forward method. And we can now run our activation function. And it works in the same way. So we just say activation redo, and it should be recognized by the autocomplete. And then we want to call an instance of that. Just call it activation. Let's say activation 1, because we might want to have a few more other activation layers. All right. It also just pops up here. And then we also want to check whether it passes on only the positive values and sets the negative values to 0. So we're just going to create a test input. Just with different numbers. And also we should include now negative numbers. Maybe another number. And see whether that's the right thing. So we have generated an instance of the activation function. And now we should be able to see the forward part if we use the autocomplete. And it also should tell us what the input arguments are. And then we just say test inputs. Sorry, that was too fast. So we just put in test inputs, and then we should see the output, and the output should only return the positive values and set the negative values to 0. And let's see whether that worked. So that's the output, and now let's compare it to the test input. And you see it makes sense, so it worked. So we can actually then link it to our network. So if we just go back to our test my ANN, then we just call our network, of course, by calling the entire module. Then we just set up the different layers as before. And what we want to do now is that and what I also showed in the PowerPoint is that we want to add this activation function after the layer. So we first call the activation function. That's what we already did here. So we just go to the part where we initialize everything, and we just call the activation function. So We can use the autocomplete again. We can the autocomplete sometimes doesn't really work in the editor. We can just copy and paste it from here. We just call the activation function. And also here, I want to keep everything in line. So, and what happens now is that we want to run or add the activation function after the output of the first layer. So we just then run activation. So let me also just run this here again, that it's defined now. And then we would do the following. We just would say activation 1, and that would require inputs. And what would be the input now? So the input would be now the output from dense layer, and in the forward part, right? Remember, there's a forward part, and we pass it on to the forward part. All right. So then it generates an output. So that's what we did already in our example here. Then it generates an output, and we feed this output into the next dense layer. We can do that because it will not change the shape or the orientation of the matrices. It will only set negative values to 0. That's the only thing it actually does. And now this should work, and we still want to test it, of course. So let me also just make some space here, and let's go through all the different steps. So we, just to make sure that we have the right module, so we just call the network again. Then we set up the different layers. So the first dense layer, the second dense layer, and the activation. Then we pass our information to the first layer. And now we just pass it to the activation function. And now it's tested again. So the first dense layer created an output. And they are all positive numbers here, so they should actually not change. And we'll also change a few numbers so that we also see that what happens to negative values. And since we have passed on the output to the activation function, now we should also see what the output from the activation function is. So you see the positive values haven't changed, so we don't have any negative values now. So let us just go up to our input, just add a few negative values, because it will also generate a few negative values then. So in principle, we can just rerun everything. We don't need to initialize those layers again. We can just use the actual instances and just run it again. So we just create an output and then also compare it to the output from the activation function. So let me just make some space again. So let us first of all take a look at the output here. You see there are a few negative numbers, and now let's do the same with the activation. And what you see is that the positive numbers have not changed, so they are all the same, but the negative numbers, the negative values are set to 0, so it's exactly what we wanted. So and then also the last test, so to say, is to pass it on to the next layer, and then it creates another output, and we can also take a look at the other output. Yeah, that's pretty much it about the activation function. So let me just go back to the PowerPoint slides and let me show you what we did. And so we first of all have our input here. Then we set up the different layers, so the two different dense layers, that what we did before. And then we initialized our activation layer with the reload function. So here we're just defining all the different layers. And then we just run them subsequently and passing on the information. So the first layer gets the input and it passes it on, then it creates an output. It passes the output on to the activation layer. It creates an output and it passes on the output to the next dense layer, which also creates an output. And also want to visualize this a bit in the graphics. So we have our three neurons here that get an input, which is 4D. And then before they pass the output on to the next layer, they pass it on to our activation function. And the ReLU is often symbolized, this graph here, just indicating that the negative values are set to 0 and the positive values are just passed on as they are. And then the information is passed on to the next layer, and those layers are creating an output. And we also checking the output. So what we did then is that we just added this activation function to our output that's been generated by the neurons. And as I showed earlier, it doesn't have to be just a reload, it can be just any other activation function. It kind of depends a bit on the architecture of the network and what you actually want to do in the network. So let us kind of summarize what we did so far. So we learned how to create layers of neurons of arbitrary size, and we also learned how to link them together. And we also added an activation function. However, our network is still not able to learn. And therefore, we have to define something like an criteria, like a so-called objective function that tells us how well does the network predict our output, so to say. So we have to compare the actual output to our target output, and we have to measure the quality somehow. So how well does the output match the target output? And we do this with a so-called objective function. So it's just a mathematical function that quantifies how well our generated output matches the desired output. And of course, that is usually not the case. So we have to train the network. So we have to find a way how to optimize this output. So we have to find a so-called objective function. And we need to optimize this objective function. And then we can always continuously compare the actual output to the target output and gradually want to improve the output. And that would, for example, work for a normal regression network if you want to fit data, for example, and we're going to show that. So, and therefore, if we want to go to the next step, and for example, if we want to do some classification at the end, that's what we're going to do at the very end when we have our CNN. Yeah, we want to have different images, and we want the neural network to learn to see what is on the images, so to classify between the different images. Let's say we have a bunch of images of cats and dogs, but it can classify these images and say, okay, that's a dog, that's a cat, and so on. And if we want to do that, and also if we want to do this with different data points and classify them different categories, then we also have to assign probabilities for the classification. So how sure is the network that, for example, this object you see on the image is a dog or is a cat? Of course, it can say yes and no at some point, but what is more helpful if we see what the probability is. So for example, if it's 99% sure that what it sees is a cat, okay, that's very trustworthy. So it says, yes, it's a cat. But if there's just a 51% chance behind the yes, it's a cat, then it's not very trustworthy. So that's already a kind of an objective function. So the probabilities the neural network assigns for the different classes. And ideally, of course, there should be always ones and zeros. Should be very sure that this is this one particular object. So it's a probability of 1 and a probability of 0 for all the other objects. So that's the idea behind this. So we need the so-called objective functions, and we also want to assign probabilities for the classification. And that's what we're going to do in the next 2 steps, actually. And therefore, we need to talk about a so-called softmax layer. And we also will talk about so-called loss and entropy.